Measurement of areas for large herbicide applications is best done in rectangular shapes, and plots should be marked as subplots of smaller areas. For example, a 200-acre area can be marked in subplots of 25 acres or smaller. This will help us keep a check on our application rate. In addition, it may be helpful to lay plots out to conform to swath width, so that a certain number of swaths will be equivalent to an acre. This will further help us keep track of application rate. Okay, we can do this by using the area equals length times width relationship, and again, knowing that there are 43,560 square feet per acre. Okay, the way we do this is to divide swath width into 43,560. This tells us how long an acre one swath width wide would be. Then we use this as one dimension of the plot, and we can calculate the other dimension by dividing the length of a 1 acre swath that we just determined into the area of the entire plot. Laying plots out this way can be very helpful for maintaining uniform coverage, because we know that with every swath we should apply the rate prescribed per acre. Alternatively, and depending on the size of the plot, we can make dimensions so that a swath is 1/2 acre, 2 acres, or other multiples. Now, let's look at an example of this type of application. Let's assume that a pellet herbicide formulation is to be applied to a 25-acre plot in a large lake with a spreader that has a swath width of 40 feet. Let's show the rectangular plot layout that would be used so that each pass would treat 1 acre. Okay, we say that the length of an acre swath equals the square feet per acre divided by the swath. Or in this case, the length of an acre swath equals 43,560 divided by 40. Therefore, the length of a 1 acre swath would be 1,089 feet. Therefore, the length of one side of the plot is 1,089 feet. Now we determine the length of the other side of the plot as follows. The area of the plot in square feet equals the area of the plot in acres times the square feet per acre. Or the area of this plot in square feet equals 25 times 43,560. Or the area of this plot is 1,089,000 square feet. Now the width in feet equals the area of the plot in square feet divided by the length. So the width in feet equals 1,089,000 divided by 1,089, or the width of the plot would be 1,000 feet. Now let's look at another example. A liquid herbicide formulation is going to be applied to a 25-acre plot in a large lake using an 8-foot boom. Let's show the rectangular plot layout that would be used so that each pass would treat 1/2 acre. Technique that we can use in this example is to skip an area between swaths, because we do know that the herbicide will move between actual treated swaths. Let's say we treat every other 8 feet. Now, our effective swath is 16 feet. Now the length of an acre swath equals the square feet per acre divided by the length of our effective swath. Or the length of a 1/2 acre swath equals 1/2 of the square feet per acre divided by the length of our effective swath. Or in this case, the length of a 1/2 acre swath equals 1/2 times 43,560 divided by 16. Or the length of an acre swath in this case is 1,361 feet. Therefore, the length of the plot can be 1,361 feet. Now, we determine the width of the plot as follows. We know that the area of the plot in square feet equals the area of the plot in acres times the square feet per acre. Or the area of this plot in square feet equals 25 times 43,560. Or the area of the plot in square feet equals 1,089,000. Now we calculate the width of the plot in feet by dividing the area of the plot in square feet by the length of the plot in feet. Or the width of the plot equals 1,089,000 divided by 1,361. And we find that the width of the plot will need to be 800 feet.